Now home fuses sometimes are easy to see if they're blown, and sometimes without a trained eye you can't tell. So a meter is very handy to have. Three kinds of fuses. The old-fashioned fast blow fuses. These are best to be used on high amperage devices like heating elements, ovens, stovetops, stuff like that. Kind is P-type. They're like a slow blow kind of fuse, and they're soldered together, and when they blow up they don't just make a black spot and have melted aluminum. They don't really make anything. They just move over a little bit, and I'll explain how they work. If this is the fuse, the little filament inside has one long piece, then an elbow on it, which is hard to see, and it's soldered to another little strip which is coming up vertical from the base. When they blow, the solder melts and they sort of lift up a little, and then you can see the tiny gap there like I've drawn now. That's how you tell if they're blown if you don't have a meter. And these third type, called fusitrons, have little metal contacts that blow too when solder melts, and a little spring tugging on them. Well, you usually can't see the part that blows when it melts, but when the spring gets short and you don't see those little spaces in there, that means it's blown if you don't have a meter to test it. Well, this is a microwave fuse. Looks a lot like the old-fashioned glass cylinder fuses in cars. When they blow, there's no visual way to tell. There is on glass fuses because you can see the blown part. So these ones have to be tested on a meter on continuity or ohm scale. These meters work great for testing resistors. Some resistors are called flame-proof resistors, and when they burn up, they look exactly the same, good or bad. So you need to have your meter to test if they're good. Unfortunately, you can't always test them in the circuit board because you get readings from other places in the circuit board. So very often you have to unsolder one end and pull it out to test them if you think that's a defective unit. Resistors come in all shapes and sizes. They can be square, round, it doesn't matter. They can be look like a coil of wire. This one says 4.7 K, so that means it's 4,700 ohms. K means multiply it by 1,000. They have different wattages. This one's about a 5 watt. The bigger they are, the more wattage. That means the more current can go through them. If you have an electric clothes dryer, it's very common that they have no heat. So the very first thing you do is set your meter to AC volts and check the two big pins, the flat ones that go into the wall, and see if they show that you have 240 volts going to your dryer, or 110 volts if it's a 110 volt apartment size dryer. If you happen to have a Kenmore, Inglis, Whirlpool or Roper dryer made since the 1990s, they might have one of these fuse things in them. It's a thermal overload thing. If they get too hot or too much current goes through them, they shut off the motor. So if you wonder why your dryer doesn't work, it either has a broken belt, which also shuts off a switch, or this thing at the back of the dryer when you remove the big access panel, sort of near the bottom left. You can't tell if they're good or bad, but if you test them with your meter, or unplug the wires going into them and sort of join the wires together temporarily with some tape, and then plug it back on the wall and test, and your motor comes back to life, well, just buy one of these little $5 parts. Simple. Of course, every dryer has a heating element. They come in all shapes and sizes. They're just a nickel alloy in there that makes high resistance when it gets hot on that coil. When they burn out, you sometimes can't see where they're burned out. So you put your meter on here and you test them, and you should also have fairly low ohms, anywhere between, say, 10 ohms to 30 ohms. If it's showing K ohms or a lot higher, well, then it's burned out. You can also test continuity between your thermal cutouts. Across there and across there should be a very low ohm reading. It means power can come through. These things only cut out if the air vent is clogged and this unit gets too hot. All the rest of the time at normal operating temperature and in just free air, they should be showing closed, which means continuity. If you have an extension cord and you're wondering why it's not working, that's really easy to test too. Stick your one probe in any hole, and then test over here on continuity setting. I hear it beeping. If you test the other one, there's nothing, because you're only actually testing one side at a time. Stick it in the other hole and test the other terminal. Then you know if your cord's good or at least one lead is broken. These meters are great for testing any kind of light bulb. Just touch one to the side and the other probe to the end, and you should get a reading of not very many ohms either. Now very often when these oven elements burn out, they burn out in a way that makes a big frazzle spot and lots of white stuff coming out, but not always. So you can't always tell if they're burned out by looking at them. Just set your meter to ohms again and they should show anywhere between 9 ohms to about 30 ohms if they're good. Same thing for these elements. If you want to test your car spark plug wires, if it's misfiring, it's easy to do too. The meter won't test if the rubber is good and it's arcing out, but it'll test continuity to see if there's a good connection all the way from one end of the wire to the other. So I've got my meter set to ohms, and it's showing me, now the sun's sort of screwing this up, but I think about 7.52K. That's fine. Longer wires inherently have more resistance, but that's okay. But generally the rule of thumb is if the wire has a resistance of less than 12K or 12,000 ohms, consider it a good wire still. You can use this meter too for also checking continuity and how good diodes are. Most times when diodes or transistors or triacs or SCRs burn out, they short to closed circuits. So if you test the leads, it always shows almost 0 ohms, a full circuit. But if they're working correctly, you put your leads on, say, positive and then negative on these two leads for the diode. So if you're testing a diode, say for example, you could randomly just put your leads on positive, negative in any direction. The thing is, just see what the reading is on the meter. Then reverse the leads, put the red over here and the black here, and check again. A good diode will always show 2 completely different readings. Or sometimes not a lot different, but they're both different. That's telling you that it's allowing more electricity to flow through one way than the other way, because that's what diodes do. They're like a one-way valve. If it shows the same reading both ways, it's most likely shorted and burned out. Same thing when you're checking transistors, or SCRs or triacs, like these things do, and you just check each lead opposite directions with your probes, and check to see if you've got different readings each way. Although the reading, what it has, isn't important, just that it's not the same and it's not showing low ohms like you have continuity or a short. These kind of meters are not effective for testing capacitors. You can kind of use these meters too to test alternators. The output terminal, even with the key turned off, should have 12 volts going to it when one lead is here and the other lead is on ground. When the key is turned on and the engine's running, it should have over 13 volts. Usually 13.7 to 14.5 is best. If you're wondering why when you change your alternator and put another new one in or a guaranteed good one in and you're still not putting out the correct voltage, well, you might not have 12 volts even coming to the alternator because the wire that goes from here to the battery is broken or the fusible link is burned. Or you can check the pins going to the exciter circuit of the alternator. You should have one lead on ground and the positive checking the pins. Usually the largest wire when the key is turned on, the thickest wire, should have 12 volts going to it, and 1 or 2 or all of the other wires should have 12 volts on them. Sometimes there's a break in the ignition circuit of the car, or a blown fuse or something, and you're not getting any exciter voltage to your good alternator, and that's why it's not putting out. Another way you can sometimes test an alternator is for a short. So you put one lead on the output, another lead to ground, and you should get almost no reading on your meter. If you get a strong connection, that means your field windings are likely burned out. Test meters are great for diesel vehicles if you want to test the glow plugs. Just put one lead on the ground shaft and one on the input pin. Good glow plugs usually have 0.7 of an ohm resistance up to about 1.2 ohms resistance. Most of the time when they're burned out, they blow and they show no reading, which of course means they're bad, but sometimes they might be weak and show like 2 or 3 ohms resistance. To test each one, you actually have to disconnect the lead or the wire that goes to each one and test them individually. Put one lead on your engine block and one lead here, and then check the reading. Of course, if one's burned out, change it, or else it'll start tough when it's cold or misfire a little bit when it's cold. So what I've just showed you is the most common applications that you would use one of your test meters, digital or analog, in a home environment or just an ordinary backyard shop or something like that, or at work. Simple. Just now you know. You can fix a lot of things now. Sweet. One more piece of advice I forgot to mention. When you blow a breaker, of course it always moves over towards the off, but usually when they blow they only move to the middle, partway to off. And most people just try to keep pushing them back to on to reset them. Well, that doesn't work. When a breaker blows, you have to push it really hard all the way to off till it clicks. Then push it back to on, and then it functions. Just thought you might want to know.